Alright folks, today what we're looking at is we're going to be looking at the factoring trinomials of the form x squared plus bx plus c. Last time we were here we were practicing factoring by grouping, which was taking a polynomial that had four terms in it, grouping them, and then factoring out the GCF. That's what we were working on last time. Today we're actually adding something to your factoring repertoire, which is going to be factoring trinomials. Now, for us to get there, what we have to do is I have to basically reintroduce you guys to the FOIL method, which is what we did about a week before we went to break, was the FOIL method, and then order to know how to essentially factor trinomials. Now, the FOIL method was, okay, when we have two binomials, okay, in this case x plus 6 and x plus 3, hope y'all can see that, x plus 6 and x plus 3, okay, and FOIL, y'all know it means first, outer, inner, last. Now, the reason I'm showing you guys this is because I hope it will help you guys understand how to do this a little better. I'm sure you recognize some of this from Algebra 1 because we do practice quadratics in Algebra 1, but this is just kind of hopefully some of this is just a refresher for y'all, and I hope to add something to what y'all know already. Okay, so say you have x plus 6 times x plus 3. Okay, FOIL method means that we multiply the first, which we know we multiply those, we multiply the second two, and then the outer two, the inner two, and then the last two, and we should get a polynomial, four-term expression. X times x should give me x squared. X times 3 is 3x. We're out of room here. 6 times x is 6x, and then 6 times 3 is 18. Okay. Now we know we don't stop there. You actually have to add the last. Not the last two. Those middle two terms because they have the same variable. So I should end up with x squared plus 9x plus 18. Now how does it really help me? Well, that shows me basically these are called factors. Okay? These are called factors, and this here is your product. When we're practicing factoring trinomials, you're given the product, and your job is to actually find what those factors are. That's your job. Now the first few are relatively elementary in comparison to this one, at least I think. Okay? As long as you know what all those numbers mean. Okay? 18, that is the product of 6 and 3. I'm sure you can see that. 9 is the sum, you can see, of 3 and 6, which are these two right here. Here's how I would approach these. Okay, if you have one here, I'll give you guys roughly 8 examples up here. I'm going to show you guys a few of these. Hopefully this will help you in your assignment for today. Okay, so here's what we have: x squared plus 7x plus 12. And what we're looking for is we know I'm going to be writing something in two different binomial expressions, a product of two binomial expressions. That's where we're coming from here. Okay, you have x squared plus 7x plus 12. Now here's what I'm looking for. Okay, this number comes from. Okay, well, similar to this number right here. That 18 comes from 6 times 3. Well, that means my two numbers here have to come from that 12 right here, okay? I know that 12 has 3 sets of factors, or at least 3 sets of whole number factors, okay? I'd say it's 1 and 12. I'd say that's 2 and 6. Hopefully you can see that. And that's 3 and 4, okay? Now what I'm looking for is a combination of those, because I know that these multiply to give me 12. What I'm looking for is a combination that add to give me 7. Well, look at these three. Now, some of y'all might have done it a different way. I think a while back, if you're in Algebra 1, some people did there's a box method you can do. There's an X method you can do. This is just the way I learned how to do it. Okay? Just find the factors here and figure out which ones give me a 7. Well, in this case, the only two combinations here that give me a 7 are the numbers 3 and 4. So that's what I'm going to do. Basically, the numbers 3 and 4 go here. I know if I add these, they're going to give me 7. If I multiply these, they're going to give me 12. The first two, obviously this one was x times x gives me x squared, so the same thing's going to happen here. X and x. It's got to give me that x squared. Now I can multiply it out to check it, but I would hope that you guys trust that that's going to be okay for now. Later, if we need more practice, we can practice multiplying it out. Okay? So that's how it works. This is your solution. Okay? That's the factored form of that specific quadratic expression. Second one looks like this. Okay? Instead of having a positive, this one has a negative here also. But the process is still the same. Okay? Process still the same. I've got x and x, okay? And I'm looking for two numbers that multiply to give me 35 and add to give me 12. Well, again, factors of 35. You're going to have 7 and 5. I'm going to have 1 and 35, okay? It's the only two really whole number factors that I can think of anyway, okay? Well, again, combination. What gives me I'm not looking for just a 12. I'm looking for a negative 12, okay? So 35 is here. Well, the only combination that gives me a 12 is what? 7 and 5, right? So that's going to be a 7. That's going to be a 5. And notice, they have to add to give me a negative. Now in this case, the only way I can combine them is if they were both negative signs. Well, how do negative 7 and negative 5 give me a positive 35? Well, if you'll recall, negative times negative is a positive. So these work out okay. So these are the factors of that quadratic expression right there. Now, it doesn't matter what order these go in. I could put x minus 5 and x minus 7 and it'd be the same answer. It's our commutative property. Remember the commutative property where you can switch orders of things. That's okay. That'll be okay there. Okay? We'll use a different color. I think this might be a little easier. But that's how that works. Okay? Third one, x squared plus 4x minus 12. 12 has several factors here. Okay? 12 will factor into 1 and 12. It'll factor into 2 and 6. And then we'll factor into 3 and 4. Hopefully you know that. Okay? Now again, what combination of those gives me a 4? Well, you know again, this is going to be x and x. Combination gives me a 12. Well, we know all those give me a 12. Which combination gives me a 4? Well, the only one that's going to give me a 4, if I combine the two, are going to be 6 and 2. It's got to be a positive 4, so it needs to be x plus 6 and x minus 2. That's what I'm looking for. Okay? That's how you factor that one specifically. Multiply them back out, I should get negative 12. Add them, I should get positive 4. Okay? One at the bottom. R squared minus R minus 42. The reason I included this one, because you're missing in this case, a coefficient here. But if you remember, don't have a coefficient, what do you assume the coefficient is? It's going to be a 1. We have to assume the coefficient's a 1 here. So right there, I'll need a 1. Right there. That's your coefficient. Okay? So factor here. You got R and R. Okay? Now, factors of 42. You could think of several. You could think of, you could say 2 and 21. You could say 1 and 42. The one that comes immediately to me, though, is 6 and 7. 6 and 7 combined to give me 42, right? Multiply them together to get 42. I combine them, they give me a negative 1. You just have to have a positive 6 and a negative 7. Positive 6 and negative 7 is what I'm looking for. So r plus 6, r minus 7 gives me that polynomial as a solution. Okay, so there's the first few set here. Those are kind of the basics here. Okay, so you're looking for a product of this number that sums to give me this one for each of those here. So hopefully you can see, again, hopefully you can see all those. Okay? Alright, next four are a little bit different, not the standard ones that you guys used to seeing, okay? But hopefully again, these work out just as well. Okay, look at this one. A squared plus 2a plus 10. Now again, you know what you're doing. We're supposed to factor this here. Okay, so let me go and put my little brackets here. Okay? Factors of 10 to add give me 2. Okay, some of y'all might know the answer already. However, look at this. Okay? 10 has two sets of factors, excuse me. Okay? 10 can multiply into 1 and 10, or it can multiply into 2 and 5. Or sorry, it can be not multiplied into. Sorry, 2 times 5 gives me 10, and 1 times 10 gives me 10 as well. Okay, excuse me for that. Alright? So, I know this is A and A. But think about this. I need two numbers that add to give me 2. Or subtract whatever. Well, look. There's no way that 1 and 10 or 2 and 5 can give me a 2. So what do we do? Well, if there's no other way to do it, in the future, I'm sure you practiced before, we're going to look at the quadratic formula on how to find what the solutions are. But for now, can we factor this? No. So what we say we can't do this. What we say is we call it one of two things. You can call it prime, or you can say it's not factorable. Okay? One of those two things. It's either prime or not factorable. That's what we're going to be able to say. Okay? So that's how it worked out. Alright? Alright? Number 6. What makes number 6 different from numbers 5, 4, 3, 2, and 1? Okay, well, notice here. This one has a y squared on the end of it. Well, no, you haven't seen those before yet. Okay? What you can do here is the factoring is the exact same way. I know this is x squared, so we know I've got to have an x and x. Okay? Well, y squared, okay? And that means I'm multiplying two terms at the end, and both of them are going to have a, well, you know, because this number right here, this 6y squared, this is the product of the last two. That means the last two each both have to have a y in them. Okay? The rules are the same here. Okay? 6, well, factors of 6. 6 factors into 6 and 1, or, in this case, or 2 and 3. Which combination of 6 and 1 or 2 and 3 give me a 7? Well, you gotta know that already. It's 6 and 1. Okay? I'm going to leave off a 1 because you can assume that there's a 1 there. So this right here is your solution. Okay? Alright, so if you have a squared variable at the end, you can assume that you're going to have another variable as your second term in each binomial. Example 7. How's this one different? Well, check this out. Okay? Notice here. Okay? The exponent of each of these. The exponent here is a 4 instead of being a square. Well, factors the same thing again. You can probably assume, but the factors instead of being x, you don't want to assume, but let's assume for now that this is x fourth, folks. That's going to be x squared. That's going to be x squared. Let's assume that because x squared times x squared, you know, is going to be x to the 4th power. Okay? 6. Again, it can either be 1 and 6 or 2 and 3. Now be really careful here, okay? Be really careful here. You're looking for a combination that gives me 5. Now it's not negative 5, it's going to be positive 5, okay? Some people have messed up on that a little bit because either one of these could give me 5. But if I do plus 6 and minus 1, that does give me a 5. However, that doesn't give me a positive 6. That gives me a negative 6. Because if I multiply those out, I'm going to get a negative 6 instead. So you can't really use those. So be really careful. Make sure all your signs match up. 2 and 3. 2 and 3. That's what 2 and 3 are the numbers we're looking for. Because 2 times 3 gives me 6. If I FOIL this out, I should get 5x squared, and then multiply the x squared times x squared gives me an x to the 4th power. This is my factored form of that right there. Okay? Example 8. All right? If you have one that's written backwards, so you have 40 minus 13t plus t squared. The only difference in this one is everything's written backwards. It's not standard form. What I would recommend us doing first is write that in standard form first. T squared minus 13t plus 40. Okay? T squared minus 13t plus 40. Okay? Hope you can tell the t's and pluses apart. Alright? So here's what we did here. So I put a t here, and a t here, I know that. Okay? Again, factors of 40. Okay? I remember factors of 40. It'd be 1 and 40, you put 2 and 20, I could have, what else? 4 and 10, and 8 and 5. Again, I'm looking for a combination that gives me 13 and negative 13 with that. The only one that works out and give me 13 is going to be 8 and 5. The only combination that gives me a 13 is 8 and 5. And notice how it's got to be negative. So that means both of these have to be negative signs in order for them to add to give me negative 13. Those are the numbers I'm looking for. Okay? So in each of these here, okay, this is an example of a prime one. Okay? Be on the lookout for those. Okay? This one has another variable at the end. Okay? So if you have another variable that's squared at the end, be aware that you're probably going to be multiplying two of the similar variables at the end. Okay? If you have one where you have, say, where you have a power that's not 2, if this is even, you should be able to multiply those. Okay? You should be able to come up with what that is right there. And then the last one, if it's backwards, okay, note that those two, you just switch it first. Okay? Now, I hope I have room over here real quick because I've got one more thing to show you. Okay? On the second part of your assignment, you actually have one that looks something like this. Let me see if I can find it real quick. Oh yeah, looks something like this. Okay? You've got something that looks like this. Okay? It says, I think it's number 23. Okay? It says you have 2z squared plus 20z plus 32. Okay? Now you have 2z squared plus 20z plus 32. Now this one is going to ask you guys, well, in the set, it asks you guys to look for a greatest common factor. This one, if you try to find out what the factors are, folks, this one's not going to work out. It's going to be a little harder to work out. What I would do first is what we did before. Find the GCF, so we did last time. Find the greatest common factor, factor the greatest common factor out first, and then do the, then factor, do the actual factoring trinomial that we've been working on. Okay? 2z squared, 20z and 32 are all divisible by 2. You should probably see that. So what I'm going to do first is actually factor out a 2 out of each of those. So that's going to be 2z squared plus 10z plus 16. Okay? So notice how I put the 2 out in front like we did last time. Put your greatest common factor out front, and then that's pretty evident to you what to do next. Factor it like you were factoring a normal trinomial. Factors of 16, add to give me 10, have to give me an 8, and a 2. Okay? That's what I'm looking for. Factor, give me 8 and 2. Okay? The reason we're studying this, folks, is this going to lead us into quadratics. All these numbers actually mean something when we're talking about quadratics. This number right here will usually stands for, this is your constant, but it will stand for your y-intercept. Your factors tell you what the locations of your x-intercept, so that's kind of why we're studying this. So, hopefully that helps. Okay? Your assignment will be posted on your paper, and best of luck. I'll be back on Friday, and and if you have any questions, we'll see y'all then. Okay? That's all we got.